Find the equation of the line passing through the point -1, 10, parallel to the line y is equal to -4x plus 5. The important thing here is the lines are parallel. So if lines are parallel, then gradient M1 is equal to gradient M2. So the equation of the line that we want to find, the gradient is the same as this line, which is -4. And we know that it's passing through the point -1, 10. So therefore that tells me what A is equal to, that tells me what B is equal to, and the equation of any straight line is y minus b is equal to m times x minus a. Put all of those numbers into the equation, so y minus 10 is equal to -4 times x minus -1, so it becomes x plus 1. So y minus 10 is equal to -4x's minus 4. Now I don't want that minus 10 to be there, so add 10 onto both sides, and that gives me y is equal to -4x's, and we've got -4 plus 10 gives me plus 6. So the equation of the straight line, which is parallel to the line given, and it passes through the point -1, 10, is y is equal to -4x's plus 6. Next one. Find the equation of the line perpendicular to y is equal to 3x minus 4 passing through the point -3, 5. Now, perpendicular lines have a product of -1. The gradients have a product of -1. So m1 times m2 is equal to -1. Now, that's in the correct format to read the gradient from. So m1 is equal to 3. So therefore m2, which is the perpendicular gradient, is equal to -1/3. We now have the equation of the line, and for every equation of a straight line I need to know the gradient at a point. So the gradient in this case is equal to -1/3. The point on the line is -3, 5. So y minus b is equal to m times x minus a. Put all your values in, so y minus b is y minus 5 is equal to -1/3 x minus -3, which is x plus 3. Don't like this 1/3 here, so multiply the other side by 3, or multiply both sides by 3. So 3y minus 3 5s are 15 is equal to -1 times x plus 3. I'm now going to multiply that whole bracket by -1. So 3y minus 15 is equal to -x minus 3. I want to get rid of that, take away 15, so the opposite is add 15 to both sides. Add 15 there and add 15 onto there. We'll now tidy it up. So therefore 3y is equal to -x, and -3 plus 15 is the same as 15 take away 3, which is plus 12. And that is the final answer, the final equation. Okay. ABCD is a parallelogram. Now, the first thing then that they're telling me, as soon as they tell me that that's a parallelogram, is that side is parallel to that one, and those two sides there are parallel. So opposite sides are parallel. So that means that those opposite sides have got the same gradient. So AB has the equation y is equal to half x plus 7/2. And the point D is the point -4 minus 1. So I want to find the equation of DC. So I need the equation of DC. The only problem is I've only got one point on that line. So how do I get the gradient? I know the gradient is exactly the same as the gradient of AB. So there is the equation of the line AB. From that, the gradient of AB is equal to a half. So therefore the gradient of DC is equal to that. So that's AB. And that's equal to the gradient of DC. So therefore the gradient of DC is also equal to a half. Now I want the equation of DC, back to the same thing that I've done in the previous two questions. To get the equation I need a gradient and I need a point. So equation, the gradient is equal to a half, and the point that I know on the line is point D with coordinates -4, -1. So therefore y minus b is equal to m times x minus a. Again, put those numbers into your equation. So y minus b becomes y minus minus 1 is y plus 1. That is equal to half times x minus a, which is x minus minus 4 is x plus 4. So therefore, we'll multiply by 2 to get rid of that half. So 2y plus 2 is equal to 1 lot of x plus 4, which is just x plus 4. So 2y is equal to x. Take 2 away from both sides, so it's x plus 2. And that's the equation of our line DC. A line makes an angle of 60 degrees with the positive direction of the x-axis as shown in the diagram. The scales on the axes are equal. Find the gradient of the line. Right, so the connection here is gradient is equal to tan theta, and theta is the angle between the x-axis and the line, and it's going in an anti-clockwise direction, so that angle is 60 degrees. So the gradient is equal to tan 60. Now that is one of your exact values. So think about your triangles or think about your tables. So gradient is equal to tan 60 is the square root of 3. Now it can be expressed as a root, or it can be left as a decimal, whatever you wish to do. Question 4. A circle has centre 8, 3 and radius 6 units. Write down the equation of the circle. So we know from our information sheet that the equation of a circle is x minus a all squared plus y minus b all squared, and that is equal to r squared. Now that's for a circle centre AB and radius r. So fill in the values. In this case we've got a centre which is 8, 3. So we change the sign and put it in there. So x minus 8 all squared plus y minus b. So b is 3. So y minus 3 all squared is equal to the radius squared, and the radius is 6, so it's equal to 36. So straightforward substitution. Now, this one here, does the point 14,3 lie in the circle? Right, so what we do is we take the equation of that circle, which is x minus 8 all squared plus y minus 3 all squared, and we know it's equal to 36. So what I do is I take the left-hand side of that equation and I'm going to substitute x equal to 14. I'm going to substitute y equal to 3. Now I'm going to calculate this left-hand side. If it equals 36, then it does lie on the circle. If it's less than 36, it lies inside the circle. If it's greater than 36, it lies outside the circle. So if I take x minus 8 all squared plus y minus 3 all squared, and we'll work that out. So x is 14, so I've got 14 minus 8 all squared plus y minus 3 all squared, which is 3 minus 3 all squared. That gives me 14 take away 8 is 6, so that's 6 squared plus 0 squared, which is equal to 36. So therefore point lies on the circle. And that's because the left side is equal to the right side. Question 5. Determine if the line y is equal to x minus 2 is a tangent to the circle. Okay, so what we've got to do is we don't know whether it's a tangent. It's not saying prove that this line is a tangent. So we'll substitute the line into the circle and we will work out the discriminant. We'll do b squared minus 4ac. If it equals 0, there's one root. If it's greater than 0, there are two roots. And if it's less than 0, it does not intersect, there's no real roots. So we want to know if it's a tangent, so we're looking for b squared minus 4ac equal to 0. Right, so we're going to sub y equal to x minus 2 into the circle. So what it means is the circle equation is x squared plus y squared is equal to 5. So every time I see a y term, I'm going to substitute in x minus 2. So that gives me x minus x squared first of all. So we'll just stick that in there. X squared plus y squared becomes x minus 2 all squared, and that should be equal to 5. X squared, nothing we need to do there. I'm going to square out this bracket the quick way, so square the first is x squared, multiply the two of them together and double it is minus 4x's, and square the last, so minus 2 squared is plus 4. Now all of that is equal to 5. Tidy up, so we've got 2x squareds, I've got minus 4x's, and I want to take 5 away from both sides because it must always be equal to 0. So 5 away from that side leaves us 0, and 5 away from this side, 4 take away 5 is minus 1. Now we're going to use the discriminant, so we're going to work out b squared minus 4ac. Now before I do that, I'm going to list the values. So there's a, so a is equal to 2, b is the number of x's, so it's minus 4, and c is the number tagged at the end without any x squares and without x's, so c is equal to minus 1. Now if we substitute that in, b squared becomes minus 4 all squared, and then we've got minus 4 times a is 2, times c, which is minus 1. So minus 4 squared is 16. Then I've got minus 4 times 2 is 8. 8 times minus 1 is minus 8. Two minuses, when we're taking away a negative, we add instead. So 16 plus 8 is 24. So what does that mean? It means that it's not a tangent, it cuts in two places. So you have to answer this question. So since b squared minus 4ac is greater than 0, the line cuts the circle in two places. So that means it is not a tangent to the circle. For the unit assessment, you do not need to know how to do this question, so I'm going to skip on to the next one. So, question 7. On a particular day at 6 AM, a doctor injects a first dose of 100 milligrams of medicine into a patient's bloodstream. The doctor then continues to administer the medicine in this way at 6 AM each day. The doctor knows that at the end of the 24-hour period after an injection, the amount of medicine in the bloodstream will only be 12% of what was at the start. Set up a recurrence relation which shows the amount of medicine in the bloodstream immediately after an injection. So we know then that immediately after an injection it's UN plus 1, and that is equal to, it's now down to 12%. So 12% as a multiplier is 0.12. So it's 0.12 times what was there in the first place, but then it's immediately after an injection. So immediately after it, he's injected in another dose of 100 milligrams. So it's plus 100 milligrams. Okay, and if you want to fill in there, the initial dose U0 was equal to 100. Okay, and that's your recurrence relation. Now, next part of this question, it says the patient will experience side effects if the amount of medicine in the bloodstream exceeds 150 milligrams. In the long term, if the patient continues with this treatment, will they experience side effects? Explain your answer. This is a classic question that's asking you to work out the limits. So, our equation, our recurrence relation was UN plus 1 is equal to 0.12 UN, and it was plus 100. So what we want to do is we want to find out if a limit exists, and it does, because this number here is between minus 1 and 1. So you have to state that. So limit exists since 0.12 is between minus 1 and 1. Now we're going to work out the limit. So when we get to a limit, all terms turn out to be the same. So L is equal to 0.12 L plus 100. Gather all the L terms together, and remember that's 1L. So take 0.12 L away from both sides. So 1 take away 0.12 gives us 0.88 L, and that is equal to 100. I don't want 0.88 L, only want L, so I'm going to divide by that. So I get 100 divided by 0.88. And when I divide that out, I get 113.6. Okay, that's milligrams. Now, back to answering the question. The patient will experience side effects if the amount of medicine in the bloodstream exceeds 150 milligrams. So it's not exceeding that. So you can say the patient, and you've got to explain this clearly, the patient will not suffer side effects as 113.6 is less than 150 milligrams. Question 8. The volume of a container can be represented by the formula V is equal to 216x minus a half x cubed where x is greater than 0. Find the value of x which maximises the volume. Right, so this is an optimisation question. So we start off by saying max volume occurs when b dash x, the derivative, is equal to 0. That's your statement. You write it down and you clearly underline it. So next thing we've got to do is we've got to work out the derivative. So v dash x is equal to, when it's 216x, multiply by the power which is 1, take 1 away from the power, but x to the power of 0 is 1, so it just becomes 216. Multiply by the power, take 1 away from the power, gives us minus 3 over 2 x to the power of 2. We know the derivative has got to be equal to 0, so 216 is equal to, or minus 3 over 2x squared first of all, is equal to 0. Now I'm going to read this round the other way, so 0 is equal to 216 minus 3 over 2x squared. I want the x squareds to be on the left hand side. I'm going to add 3 over 2x squared onto both sides. So 3 over 2x squared is equal to 216. To work out x squared, we've got 3 times x squared divided by 2. So the opposite of dividing by 2 is to multiply by 2. The opposite of multiplying by 3 is to divide by 3. So therefore x squared is equal to 216 multiplied by 2 all divided by 3. So when we work that all out, we end up with a value of 144. Now that's what x squared is. I don't want x squared, I want x. So x is equal to plus or minus the square root of 144. So either x is equal to plus 12 or minus 12. Now, what was x? Go back. This is about a container, and it's about a value of x, and x represents a length. So therefore, we can't have a negative length, so we'll discard the minus 12. So cannot have x equal to minus 12, since it's a length. So therefore, x has got to be equal to 12. Now, we always have to draw a nature table to show that it's a maximum value. So set up your nature table. That's x, and this is v dash x. And we're going towards 12, and we're going away from 12. We put just a wee arrow in there instead. So we're going towards 12, and we're going away from 12. So choose a value, say 6. Choose a value, say 8. And at this point, you can cheat. We know it's a maximum, so I know it's got to look like that. That's a maximum value. So therefore, it's sloping uphill, which is positive, 0 and negative. So you would just finish that off by saying max value or max volume when x is equal to 12. And it's important that you do that table. For this one, it says a curve has equation y is equal to x squared bracket x minus 4, and it's shown below, and we've got to calculate the area under the curve. Right, a couple of things that we need to realise before we start. We need to find the limits, which is this point here and this point here. So the limits are when the curve crosses the x-axis. So it crosses the x-axis when y equals 0. Now, in the question, they've already factorised this for me. That's a tool you would use to work out your roots where it crosses the x-axis. But if you look here, you can see that they've already factorised it for us to make it easy. So, y is equal to 0. So that means in the x squared bracket x minus 4 is equal to 0. So either x squared equals 0, giving me x equal to 0. That's that point there which we knew it's sitting in the origin. And either x minus 4 equals 0, giving me a value of x equal to 4. So I've now got both of the limits. Now the area under a curve is given by the integral, so it's the integration. So the area under the curve is the integral from 0 to 4 of this equation here. Now one thing I've got to know is when I work out this integral, this will turn out to be negative because it's below the x-axis. An area cannot be negative, so when we change it to an area calculation, we change the negative to a positive. So I'm going to work out the limit from 0 to 4 of x squared bracket x minus 4, and remember dx, don't forget to put that in. That's not in a format where we can take the integral, so I've got to multiply that bracket out first. So I'm still not taking the integral, I'm just getting it ready to integrate. So x squared times x is x cubed, and x squared times minus 4 is minus 4x squared. And don't again forget dx. Right, we're now at the stage where we can take the integral, so I'm going to change to square brackets and transfer your limits over to the right hand side. Now, to integrate, add 1 onto the power, divide by the new power, so that becomes x to the power of 4 over 4 minus, there's a 4 already there, so I'll leave it, and that's x to the power of 3 all divided by 3. Now to work out that definite integral, I substitute in the upper limit, which is 4, substitute in the lower limit, which is 0, and we subtract. So I'm going to change to curved brackets so I can do the substitution. So we've got 4 to the power of 4 divided by 4 minus 4 times 4 to the power of 3 divided by 3, and next bracket I'm substituting in 0, so it's 0 to the power of 4 over 4 minus 4 times 0 to the power of 3 divided by 3. Now of course this bracket will all be 0, but you write that in. Now 4 to the power of 4 divided by 4 is the same as 4 to the power of 3. So 4 to the power of 3 is 4, 4s are 16, times 4 is 64. And that's minus 4 times 4 to the power of 3 we worked out a minute ago is 64, and we've got to divide that by 3. All of that is equal to 0. So all we have to do is to tidy this up. So that is 64. And when I work out this second bracket, 4 times 64 is 256, so it's minus 256 over 3. Now, I want to change them all into same fractions. You can use your calculator. I don't have one here just now. So we'll do 3 times 64 and change that into thirds. 3 times 64, 3 4s are 12, 3 6s are 18 and 1's 19, so it's 192 thirds. And I want to take away 256 over 3. So you can see that that number's bigger. So we're going to get a negative value for our integral, which is perfectly correct. Right, so 192 take away 256. That works out to be minus 64 over 3, which is equal to minus 3 into 6 goes twice, 3 into 4 goes once, and there's 1 left over, so it's minus 21 1/3. Now we were asked to calculate the shaded area, so we now write down shaded area, drop the negative sign, so shaded area is equal to 21 1/3 square units.